Okay, 6.1 number 17. Here we go. So 6.1 number 17. A couple of you had questions about this one. And I gave you this hint, right? That this is how you would set the thing up. And so maybe I'll give you a little bit of explanation as to how I arrived at that. Although I suspect that's not the problem. But anyway, but we'll talk about that. But I suspect what's giving you trouble is this absolute value business, and you're not sure how to handle the absolute value thing. So let's take a look. 6.1 number 17 it says sketch the region enclosed by the curves and then find its area. And so we've got y equals 2. Let me write this down. So this is 6.1 number 17. We've got y equals 2 plus square root x minus 1, and then y equals negative 1/5 x plus 7. Okay. Okay. Well, as you can see, I just did number 39 from 6.2 up here, but let's see. Y equals 2 plus absolute value of x minus 1, and then y equals negative 1/5 x plus 7. I'm going to use a pencil for this one because I think I might have to adjust my graph because really, I mean, you kind of have to figure out where these things are intersecting. Now, actually, on the other hand, let me just say, one way to figure out where these things intersect would be to set them equal to each other and then solve for x. That might be easier. That way I don't have to go backtrack. So let me do that first. Okay, so the key for problems like this is to understand what absolute value of x minus 1 means, right? So absolute value of x minus 1 means that if you plug in a value for x and the answer you get here is negative, well then you're going to make it positive. And if the answer you plug in here is positive, then you're going to keep it positive. So notice that if x is 1 or larger, right? So like 1 minus 1 is 0, 2 minus 1 is 1, 18 minus 1 is 17. So if x is 1 or larger, then the stuff inside of here is going to be positive. So we can say something like this. So let's say if x is greater than or equal to 1, then the absolute value doesn't really do anything, right? You just are left with 2 plus x minus 1 without the absolute values. Equals negative 1/5 x plus 7. The other case is if x is less than 1, right? So if x is less than 1, so like if x is 0, you get negative 1. But you have to negate that so that it becomes positive when you take the absolute value. So the other case is if x is less than 1. And in that case, we're going to, actually, I should just write it like this. We're going to negate the thing, right? And then you can just solve for x from there. So this looks like it's going to be x plus 1 equals negative 1/5 x plus 7. We can subtract the 1. We can move the 1/5 over, so we're going to get 6/5 x equals 6. Multiply by 5, you get 30. Then divide by 6, and you get 5. So there's one place where it's going to intersect. And 5 is bigger than or equal to 1, so this is not like a degenerate case or something like that. Okay, here we're going to have negative x minus 3. Oh, sorry, no, that's a plus 3, right? 2 plus 1 is 3. Okay, equals negative 1/5 x plus 7. And again, I can add the 1/5 x over to the other side, and that'll make this a negative 4/5 x. And I can subtract the 3 and get 4. Multiply by 5, you get 20. Divide by negative 4, and you get negative 5. That's interesting. Okay, negative 5. And negative 5 is less than 1, so again, there's no contradiction or anything. So you know that the two graphs are going to cross at 5 and negative 5. Okay, so this is good. Just in terms of being able to graph it, I know where the graphs are going to intersect now. So I know that I need to draw my graph going from, and I think most of the action is going to take place up above the x-axis. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For y equals -1/5 x plus 7, the y-intercept is going to be at 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1 over 5, which puts me there. Or I could go up 1, left 5, which would put me there. So there's my straight line. Okay. As for the absolute value, 2 plus x minus 1, this is just a normal V-shaped absolute value that's been shifted right 1 unit and up 2 units. So right 1, up 2, and then it's going to go like this, right? So up 1 over 1, up 1, and over 1, up 1, over 1, up 1, over 1. Sure enough, they intersect right at that point, right? They're also supposed to intersect at -5, which means it's going to go through that point right there. Okay, but you could play the same game up over, up over, up over, up over, up over, whatever. You end up there. So the picture you get, right, should look something like that. There you go. So we were supposed to draw the picture, and there you go. We've drawn the picture. Okay, now the question is, what is the area? Well, so the area is going to be the integral from -5 to +5 of top function. That would be the y equals -1/5 x plus 7. Minus the bottom function. That would be the 2 plus absolute value of x minus 1. And there's the setup. Okay, so that I think gets us to, that gets us here, right? Yeah, same thing. So then the question is, how do you take care of this absolute value when you go to do the integral? Well, you do the same sort of thing as what we reasoned out here, right? And you realize that, if x is bigger than 1, bigger than or equal to 1, this absolute value does nothing, so you can just drop it. If x is less than 1, then the absolute value just has the function of negating whatever you get inside of the absolute value. So you can just write it as 2 minus, in parentheses, x minus 1. So if you split the integral at 1, then you can rewrite this function in the 2 appropriate ways. So you can say, all right, okay, so this is the integral from -5 to 1, right? I'm going to split it at 1. So it's the integral from -5 to 1 of -1/5 x plus 7 minus 2. Now remember, if x is less than 1, which is the case if you're between -5 and +1, so if x is less than 1, you have to negate that thing. So it's going to be 2 minus, so many parentheses. Okay? And then you're going to add the integral from 1 to 5 of -1/5 x plus 7 minus, this time, if x is bigger than 1, which it would be if you're between 1 and 5, you can just drop the absolute values. They're not really doing anything. Okay. Okay. So let me just take this one step further, and then I'll leave the rest up to you, because from there it's not difficult at all. But we can clean this up so it's not so scary looking. You've got a -1/5 x minus a negative x, so that's plus an x. So -1/5 x plus x should be 4/5 x. And then for the constants, I've got 2 minus negative 1. That's 2 plus 1, so that's 3. So I've got 7 minus 3. 4. Okay, so there's that first integral. And then the second integral from 1 to 5. We've got a negative 1/5 x minus an x. So that's going to be a negative 6/5 x. And then 2 minus 1 is 1. 7 minus 1 is 6. So plus 6. And there you go, right? So the rest is easy. The rest is easy. I'll leave the rest up to you. So that's it. That's 6.1 number 17.